how to calculate the acceleration of a pulley system like this one through the long way where we show our work. So first of all, we're going to write expressions, okay? So we're going to have tension 2. Let's just say this is tension 2 and this is tension 1, okay? Tension 2 will equal to, there is a force of gravity and the net force present. So that means, because we've had, I don't know why I crossed that out, we have a net force which is going to be tension plus gravity, which if our reference coordinates are, you're going to say down is positive, tension is negative. So then tension, after arranging the formula like this, is going to become mass gravity minus mass times acceleration. And this is all for mass 2. Okay, now that's the expression for this object. The second expression for this object is going to equal tension 1 equals mass 1 times acceleration. So this is really helpful just to understand or remember. It's pretty obvious because of the free body diagrams that will show you where these equations come from. There are only vertical forces causing a net movement, and there's only horizontal forces causing the net movement. So to solve for the acceleration, we are going to assume tension 1 equals tension 2, which means because this is tension 1, we're going to substitute this in here, which will give us the equation mass 1 accelerations equals mass 2 times gravity minus mass 2 times acceleration. So after isolating and factoring out whatever we need to simplify the equation, what we end up with is going to be acceleration equals the second mass divided by the net mass of a system. So then if you were to show your work, this is a long way which you could get the acceleration of this pulley system. So now that we got that acceleration is basically equal to this, that applies for the previous example of that specific pulley system where there is only one mass causing the acceleration. Now what if there are different masses present, like a pulley system such as this, or a pulley system such as this one? Well, the end is the equation will still be similar like this, except this top is going to alter, because what's actually going on is it's not one mass causing the acceleration. It's going to be the difference of mass between the two objects we have. So for example, if this were 2 kg, this were 4 kg, then you would need to get, it would not be mass 2 anymore. It's going to be the difference. So this here is going to be 2 kg, because how is that going to work? Because if we take a look, the net force is equal to the force of object A plus force of object B. Back in that earlier example, there's only one force, so it's going to be for F net equals mg, so like that. But now here it's going to be mg plus mg because of the two masses we have here. And to factor that out, it's going to be mass minus mass, mass minus mass times gravity. And then in these cases where there are two objects on the pulley system, instead of what we got earlier, instead of mass 2 times gravity, it's going to be mass 2 minus mass 1 times gravity, or mass 1 minus mass 2, because we're looking for the difference in the mass that is causing the acceleration. Okay. And if you want to calculate for friction, you would just minus friction right here. And the rest is the same. The total mass of a system, and for this case, you would need to add this into the mass of a system as well.